In September 2023, Earth pulsed with a mysterious rhythm. Every 90 seconds, a tremor echoed globally. No earthquake, no explosion, yet the entire planet quivered. It was as if Earth itself had developed a pulse, a heartbeat not of blood, but of stone and seawater. The signals came and went with eerie precision, too patent to be dismissed, too strange to be explained. Something ancient and massive had moved, and the world had felt its breath. Scientists across continents scrambled for answers. From seismic labs in California to oceanographic institutes in Norway, experts pored over data that defied every known geophysical model. Instruments registered the tremors, but their origin remained a ghost. No tectonic slip, no volcanic boom. It was a haunting anomaly, one that chipped away at our confidence in how well we truly understand Earth's hidden systems. Worse yet, the pattern wasn't random noise. It was rhythmic, consistent and global. Researchers wondered, could something entirely new be happening inside Earth? Was it a rogue wave of crustal deformation, or perhaps a symptom of a planetary process previously undocumented? The need to locate and understand this anomaly wasn't just about solving a riddle, it was about safeguarding humanity against geological events we don't yet fully comprehend. The first real progress came from a team at the University of Oxford. Graduate researcher Thomas Monaghan, working under Professor Thomas Adcock, dove into the puzzle, not as a geologist, but as a hydrodynamic engineer. Their fresh perspective offered a way to interpret the world not just through seismic pulses, but through the motion of water itself. Their investigation hinged on the Surface Water and Ocean Topography Mission, SWOT, a next-generation satellite launched in December 2022. Developed jointly by NASA and France's CNES, with contributions from the UK and Canada, SWOT's K-band radar interferometer, or CARIN, scanned Earth's surface with millimeter-scale resolution. Its mission was to monitor rivers, lakes and oceans in fine detail. The satellite passed over Greenland repeatedly, building an almost time-lapse view of water bodies and elevation changes. What it saw, no one expected. In a study published June 3, 2025 in Nature Communications, Monaghan and Adcock unveiled the truth. The tremors came from a series of massive seiches, enormous oscillating standing waves trapped inside Greenland's Dixon Fjord. These waves were not caused by tides or winds. Instead, they were born from something far more violent, a glacial-triggered landslide powerful enough to displace the ocean itself. It was a cataclysm born of ice and gravity, broadcast silently through stone. The story begins on the rugged frozen coastline of East Greenland. On September 16, 2023, a towering cliff face gave way, shearing off a chunk of mountain estimated to contain over 25 million cubic meters of rock, sediment and ice, more material than the entire Great Pyramid of Giza. The mass plunged into Dixon Fjord with cataclysmic force, displacing a wall of water that rose up to 200 meters high, dwarfing anything human civilization has ever built. But the tsunami had no ocean into which it could disperse. The fjord's steep granite walls and narrow length turned it into a chamber of echoing waves. Trapped, the energy rebounded again and again, water surging and retreating, caught in a cycle that persisted for 9 days. Each oscillation hammered the seafloor, sending vibrations down through Earth's crust. These vibrations spread invisibly across continents, recorded by instruments but missed entirely by human senses. Inside the fjord, a massive underwater pendulum had formed, water crashing from one end to the other like the breath of a trapped giant. The timing was almost surgical. Every 90 seconds, a fresh seismic pulse radiated outward, like a heartbeat refusing to fade. The math behind the forces involved is staggering. Monaghan calculated the motion's thrust at 500 giganewtons. To visualize that, imagine 14 Saturn V rockets igniting at once, or an invisible fist slamming into Greenland's bedrock again and again, once every 90 seconds. Despite the magnitude, there were no screams, no fleeing wildlife, no alarms. The fjord remained hauntingly quiet, untouched by human presence. Even a Danish naval patrol ship that entered days later found a deceptively calm scene. Only through SWAT's eyes could the hidden truth be seen. The satellite's radar detected faint, repeating changes in the fjord's surface height, oscillations invisible to the naked eye. Cross-referencing these with seismic recordings and running complex fluid dynamic simulations, the Oxford team pieced together the unseen catastrophe. They recreated a geophysical ghost story in stunning detail, and they solved one of Earth's most peculiar mysteries. But this was more than a scientific marvel. It was a harbinger. The collapse in Dixon Fjord is part of a broader growing pattern, one driven by climate change. As glaciers retreat, they leave behind oversteepened slopes of unstable rock. These slopes, once pinned by ice for millennia, are now vulnerable to collapse. In regions like Greenland and the Himalayas, landslides of this scale are no longer improbable. They're increasingly inevitable. A single unmonitored landslide in a remote region can now have consequences detectable around the world. Coastal communities, power plants and shipping lanes are all at risk. And because these Seiche-induced tremors can mimic tectonic events, they risk being misclassified or misunderstood, delaying emergency responses or skewing seismic data used in disaster modeling. This is where advanced satellite monitoring becomes a game changer. SWAT wasn't designed to detect tsunamis, yet it did. Future missions may be tailored to spot surface disruptions from landslides or other mass movement hazards. In combination with artificial intelligence and machine learning, this creates the potential for automated hazard alerts, providing early warnings not just of earthquakes or volcanic eruptions, but of the silent surging violence of water itself. The implications ripple far beyond Greenland. As the Arctic thaws, dozens of similarly shaped fjords, glacial valleys, and unstable cliffs lie in wait. Some are near scientific stations, others are adjacent to indigenous communities, and all of them sit in dynamic, shifting landscapes shaped by a warming atmosphere. Climate change is giving rise to new, unseen extremes, Monahan warned. We're entering an age where the boundaries between geology and climatology are dissolving. Adcock echoed the urgency. This was an event we wouldn't have understood a decade ago. We now have the technology to see it, but only just. For 9 days, the Earth rang with a pulse from a hidden, ice-carved fjord, a rhythm born not from tectonic plates or magma, but from melting glaciers, crashing cliffs, and oscillating seas. It was a message from the edges of the map, a signal that our planet is changing in powerful and unfamiliar ways. The question now is not whether it will happen again, but where and when. As our understanding deepens, so too must our awareness. To stay ahead of the next discovery, one that may be unfolding right now, unseen, subscribe to our channel, because the Earth has stories to tell, and some of them are still echoing through stone.